Fine, let's start. So, as Karthik mentioned, yesterday we have finally seen the outlier detection and also we have seen the practical explanation. Fine. So, I hope now we are good with these concepts, right from the normal distribution to standard normal to the empirical rule. Fine. And also outlier detection part. Okay, fine. So, now today we are going to see few concepts. Okay. Uh, you can call this like a general concepts, and then we are going to uh, see few other distributions also. Okay, fine. See, let's start. uh, First thing, yeah, there are two things we are going to discuss. Okay, one is called as skewness. Okay, one is called as skewness, and other thing is called as kurtosis. Okay, other thing is called as kurtosis. Okay, we'll see. But one thing you need to remember in statistics is there are something called as moments, guys. Moments. Okay. In statistics, fundamentally, there are like four moments. Fine. So they are like mean, variance, skewness, kurtosis. Okay. This is called first moment, this is called second moment, this is called third moment, this is called fourth moment. Okay. Moments. Fine. So regarding the skewness, okay, I think skewness is not a new thing for you guys because we have seen so many times the skewness. What is skewness, guys? Anything which is not symmetric, right? Anything which is not symmetric. So there is some skewness. Agree? So as already shown. So yeah, over here, if you see, this is positively skewed because in the positive side, right side, we have the long tails. Fine. And this is a negative skew. Okay, fine. But let's see how to calculate skewness and how much skewness is considered to be okay and things like that. Okay, see, first of all, if you see how you can calculate skewness, yes guys. So yesterday in this example, when I was showing this example, okay, so or any other example, okay, even this graph, if you might have observed, all these are like are not perfect normal. Agree? All this does not look like perfectly normal. You can see slight fluctuations over here, yes, small ups and downs. Okay, that means it's not like 100% normal. There is some degree of skewness. Okay, because even in real life also, it is very difficult to find a 100% perfect normal distribution. Okay, there will be some fluctuations. Fine. So, but how much is the skewness? If you want to know, it's very simple. Okay, so you can do this. Okay, the data frame d dot sepal length dot skew. Okay, this is the skewness which the sepal length is having. And what is the sepal length diagram? Mm, yeah, as you can see, okay, as you can see, it looks like a normal, but a small fluctuations, right? So maybe here, okay. That's why it's not exactly zero. There is some degree of skewness. Agree? Similarly, you can also see some petal length is okay. It's also some degree of minus 0.04. Okay, and petal width some degree. Sepal width is minus 0.29. Okay, what is how does sepal width look like? Let's see. Okay, yeah, this is almost looking like a normal. Okay, but I might say over here might be okay. Fine. So this is to calculate the skew. It's very simple. Just data frame dot skew will give you the skewness. Okay. So, but how much skew can be considered? I have noted down here. So see, if the skew is between minus 0.5 to plus 0.5. Okay, it can be considered as almost no skew and can be considered as normal for practical purposes. Okay, but if it is between minus 1 to 1, it is moderate skew. Okay, it is a moderate skew. There is some skew you can clearly observe. Anything greater than this, that means greater than 1 or less than minus 1, okay, there is absolutely some degree of skewness. Okay, then you need to handle that. Fine, fine. Because why we are studying skewness? First thing, as I said yesterday, since we have studied and understood normal distribution, standard normal distribution a lot, so every concept which we are going to study from now is directly related to this concept normal distribution or indirectly related to this, or it will be revolving around this concept only. Okay, either, as I said, either we are checking if it is a distribution is normal, or whether we are converting it into normal. Okay, or we are checking how much it is deviating from normal. Okay, like that. Fine. So why? Because our lives will be so much easy once we are able to convert or find a normal distribution. Fine, fine. So now that's the reason. But what is the opposite thing to normal? What is it? What is that one thing that is stopping from being normal? It is skewness. Agree? When there's absolutely no skewness, then it's perfectly normal. Fine. But if there is some degree of skewness, then it is deviating from the normality. Agree? So that's the reason you need to check, like if it is small skewness, as if it is between minus 0.25, 0.5. So even though it's not perfectly normal, you can still consider as normal for all practical purposes. Okay. But if it is between 1, minus 1 to 1, you need to think a bit greater than that, absolute skewness. Okay, fine. So that's regarding the skewness. Let me know if this is clear. Okay.
Yes, sir. Yeah.
Okay, fine. I hope that's clear. Now, next thing is something called as kurtosis case. Okay, as you can see here, the fourth moment in statistics, it's called kurtosis. Fine. So regarding kurtosis, if you see, okay, see, I'll explain you in detail what is kurtosis, but as an overview, if you observe, the kurtosis actually deals regarding the spread of the distribution. I mean, whether it is you can say the vertical, in the vertical direction. Okay, here in the skewness, you are checking in the horizontal direction. That means whether the graph is moving like this or whether the graph is moving like this. Fine. Like how much the tails. Okay, you are checking how much tails are getting elongated. Fine. But coming to kurtosis, okay, you are seeing the spread of the direction, spread of the distribution. That means what? That means how much it is like varying in the vertical direction. Fine. So that means if you see the mean of all three graphs, okay, the mean of all three graphs is same. You agree? See, this is the mean, this is the mean, this is the mean. Okay, the mean of graph A, B, C is same. Okay, but still they are different because the spread, or you can say, if you remember, the standard deviation of variance is different. Fine. So that will be okay studied using kurtosis. That means here also a perfect, if you see the middle one, okay, this one, this is a perfectly normal distribution. Fine. So as I said, we are going to always point our finger towards normal distribution. Here also, the perfect distribution is what? The perfect distribution which we want is something like this. Fine. If it is deviating in one way, positive, it is deviating it another way, it is negative. Fine. So here also, perfect distribution is this normal distribution. Okay. So, but if the tails are okay, if the tails are smaller, okay, and if it is getting pushed in the vertical direction in the upward, okay, then it is a positive kurtosis. Okay, we'll see there are different names for kurtosis, but this is one type of kurtosis. Okay, but if it gets pushed to the down and it spreads, okay, and if it spreads, right, and it becomes another type of kurtosis. Okay, you can call it as negative kurtosis, but it is another type of kurtosis. Okay, so I think I have a diagram regarding this. Let me, yeah, exactly. So skewness, yeah, will actually uh, like focus on the symmetry. Fine, and that means when you cut the graph vertical cut, that means if you just cut it into two, how much the left side portion is equal to the right side portion, that is what skewness will think about. Okay, but coming to kurtosis, it will be the horizontal part. Okay, how much the head, we'll see, but it fundamentally checks how much the proportion of head is available in comparison to the tails part. Okay, whether the tails are very small or whether the tails are getting elongated in comparison to the head part, whether it is getting peaked over here. Okay, so we are going to study that with the kurtosis. Okay, but fundamentally, why are we doing all this? What is the point? Okay, because we are trying to see how much it is deviating from the normal distribution. That's all. Fine. So if it is not deviating much, then we are happy, we are lucky. Fine. So then we'll go and take the distribution, assume that as normal distribution, and apply all the rules and formulas of normal distribution. But in nature, it is most of the times it is difficult to find out a normal distribution. That means, see, I only said it is normal distribution. Fine. I said like most of the distributions follow normal distribution. That is true. But when we are speaking specifically and like I would say with what you can say, yeah, with maximum degree of confidence, so we need to be very specific. Okay, we need to see it is normal, but how much skewness it is having. Okay, you cannot roughly casually say it's normal. So how much degree? So is it 90% normal, 100% normal, 95% normal? So it is very difficult to find a 100% normal distribution in real life. Okay, so that's why we are studying these concepts to see how much it is deviating from the normal distribution, whether we can assume it is a normal distribution or not. Okay, fine. So regarding the kurtosis, right? So there are actually a few things which we need to understand. So we'll quickly try to understand those. Okay. See, kurtosis is a measure of the tailness. Okay, kurtosis is a measure of the tailness of a distribution. The tailness is how often outlier occurs. Okay, excess kurtosis, tailness, and distribution into normal distribution. Okay. So there are two things, guys. One is actually regarding kurtosis, it's the same thing, but people have started measuring it in two ways. Okay, one is a actual kurtosis. Okay, and second thing is a excess kurtosis. Now, excess kurtosis is something which is measured with respect to the normal distribution. Okay, with respect to the normal distribution. Okay, this is actual without any difference. We will measure the kurtosis. Second thing is the with respect to normal distribution, how much extra this peakness or tailness is available. Okay, in the given distribution, that is with respect to normal distribution. Okay, when we measure with respect to normal distribution, it's called excess kurtosis. Okay, we will see an example, you will get an understanding. Okay, but now the main point over here is okay, the main point over here is in kurtosis there are actually three types of kurtosis. Okay, so one is it's called mesokurtosis. Okay, or mesokurtic. Fine. So if I just give you an overview, so let's say you're having kurtosis. Fine. See, guys, it's simple. One is called as mesokurtosis. Okay, let me just write it as M. Okay, M is for mesokurtosis. Now, in mesokurtosis, the distributions with medium kurtosis, medium tails. Okay, it's not smaller, not not fatter, not thinner. Okay, it is medium tails. Now, this will come under what? This will come under normal distribution. Okay, normal distributions are example for the mesocortex. That means they're having medium tails. Okay, and before that, yeah, I'll show you. See here. Okay, before that, Distributions with low kurtosis, that means thin tails. Okay, distributions with thin tails are called as what? Plato. Okay, P. Sorry, platykurtic. Okay, it's called, it will be Greek and Latin names, don't worry, but it's called as platykurtic. Okay, here it is thin. Fine. And the distributions with fat tails are called leptokurtic. Okay, leptokurtic. Okay, here it is fat. Okay, now these are the kurtosis values. Fine, these are the kurtosis values. Now, kurtosis divisions. Fine. So normal, thin tails, and here it is fat tails. Okay, lepto, meso, platy. Okay, fine. You can remember platy as flatty. Okay, flat, thin, like that. Now, if you see the examples, tails are tapering ends on the other side of the distribution. They represent the probability or frequency of values that are extremely high or low compared to the mean. In other words, tails represent how often outliers occur. Yes. So if you see here, the whole scenario is we are measuring with the respect to tails. Okay, but why tails are important? Because tails are the thing where most, if the tails are getting elongated, so that is actually increasing the frequency of high values or low values when compared to mean, which can become outlier. Agree? Because what are the outlier? Fine, outliers are some values which are not actually following the remaining values, right? So what is the probability? Where is the actual probability you can find an outlier? In the tails itself. Agree? Because very low values or very high values are outliers. Agree? Most of the values can be found inside the distribution, but if the value is as I said, if you take height, okay, 4 to 6 is a usual height, fine. So here you will have 4 to 6, fine. But if your height is like extremely low, 2, fine, so that will become an outlier. Okay, where you will have it in the extreme ends, or 10, okay, you will have it in the extreme ends. Okay, so ends in the sense the tails part. Okay, so that's why tails are the location where there is more possibility to find the outliers. Fine. So now here, if you see, as I said, like 3 parts. One is meso, that means if you focus on the middle part, okay, this is mesokurtic. And what was about the plating? It is thin. Okay, thin tails. So for platy, if you see, okay, there are no tails at all. Okay, directly the distribution started. Fine, this is thin tails. Okay, this part. Okay, but coming to lepto, okay, here if you see this much fat tails. Agree? Fine, so it started like this. It started off like this, and from here the distribution started. Okay, but the other one is just small tail, but actual distribution started like this. Okay, I hope you are able to see the difference. Fine, so this is normal, and this is fat tails. Okay, fine. So just 3 things you need to remember. Meso, down you will have flatty, thin tails. Above you will have lepto, fat tails. Okay, that these are the three different distributions, guys, in the kurtosis. So there are different measures how you can measure the kurtosis. Okay, so I have given you the overview. As I said, you will have meso, platy, lepto. Tailness, coming to tailness, medium tail will be the meso. Platy is, as I said, thin tails. Okay, lepto, fat tails. Agree? Now, outlier frequency. Okay, there will be medium outlier frequency. Okay, low outlier frequency. Okay, lepto will have chances of high outlier frequency. Why? Because lepto is having the maximum amount of tails, fat tails. Okay, here if you see, it's having fat tails. Okay, so this is a fat tails. Okay, so in the tails region is the one which is reason for the outliers. So it is having fat tails. So there are more chances of outliers. Okay, medium. Okay, Plato, there are no tails at all. Okay, almost the distribution started off here. Okay, there's small amount of tails. So that's why it is low outlier frequency. Okay, fine. But the important point is this, the next two. One thing is, see guys, for a normally the kurtosis for a normal distribution will be equal to 3. Okay, the kurtosis, the average value, okay, the resting value is 3. Okay, it's called 3. Anything less than, okay, anything less than 3 is what? Plating. Okay, so this is 3. If you see miso, it will be 3. Okay, it will be 3. If you go down, anything less than this, it will have, okay, less than 3 will be plating, and greater than 3 up will be lepto. Greater than 3 will be what? Lepto. Okay, that's why less than 3, greater than 3. That is what? That is kurtosis. Next thing what we have is the excess kurtosis, guys. What is excess kurtosis? Is the tailness of the distribution related to normal distribution? Okay, as I said, this is related to normal distribution. Okay, because as I mentioned it many times, okay, always we are focusing or we are concerned about the normal distribution. So that's why we have invented a new type of kurtosis just to see its relative tailness with respect to normal distribution. Okay, because our aim is to see how much we are deviating from the normal distribution. Fine. So actual kurtosis is without any reference. Okay, the actual tail and head proportion. Okay, but excess kurtosis is with respect to normal distribution. Okay, so that's why with respect to normal distribution. Okay, so as you can see, kurtosis, when it is mesokurtosis, that means medium. Okay, that means moderate. It is actually a normal distribution. Okay, this is a normal distribution. So that's why excess kurtosis. Okay, that means normal distribution with respect to normal distribution, it will be 0. Agree? For now, because excess kurtosis is what? With respect to normal distribution. Okay, when you are comparing normal distribution, okay, and meso will be normal distribution, it will be 0. Fine. And coming to platic-kurtic, okay, so it will be somewhat lesser than 3. Okay, if it is lesser than 3 here in kurtosis, then it will be lesser than 0 in excess kurtosis. Okay, aggregate. So if it is normal distribution, sorry, if it is normal kurtosis, then this is 3. Okay, what? 3, sorry, 3 greater than 3, less than 3. Agree? Normal kurtosis, but normal kurtosis. But if it's excess kurtosis, okay, just you are shifting the values. Now 3 becomes 0. Okay, now if 3 becomes 0, okay, now less than 3 becomes less than 0, and greater than 3 becomes greater than 0. Agree? That means this became positive, this became negative, this became 0 only. Okay, that's why this became negative plating and this became positive lepto. Agree? Now examples are, as I said, meso will be normal. Okay, and for plating it will be uniform and it will be Laplace. Okay, and we'll see this example, so don't worry. Fine. Okay, but there is one important point I need to mention. Okay, even though you have two kurtosis, excess kurtosis and kurtosis, usually what happens, right? People will call excess kurtosis by just kurtosis name. Okay, because most of the time we are just concerned about excess kurtosis, because the actual kurtosis how much we don't need or we don't care much, because what we need to do with the kurtosis, we want the kurtosis with respect to normal distribution, so that I can understand whether I can assume my distribution as a normal distribution or not. Okay, so that's why it's called excess kurtosis. But as I said, you should be little cautious. Okay, because normally people call excess kurtosis as just kurtosis, and they will give these values. Okay, so how to find out is if the value is negative. Okay, not always but mostly, because here also it could be sometimes negative, but it will be extremely, if it is extremely less than 3, then it will become negative. Okay, but practically if the kurtosis value is less than 0, okay, you can consider it as plating. Okay, if it is greater than 0, positive, you can consider it as lepto. If it is 0, around 0, even if it is not perfectly 0, around 0, 0.11, something like that, it would be mesokurtic distribution. Okay, so this is the overview of kurtosis. Is the theory clear, guys? Let me know. Okay, so I hope you are good with the theory. Fine. So I'll show you some examples. Don't worry. So that you can understand. Okay. Yeah. So here, yeah. the way how you can, okay, what is 3 in Kurtosis? Srish is asking what is 3 in Kurtosis. See, Srisha, as I said, if it is a usual Kurtosis, okay, the value they started is measuring with 3. Okay, there is no specific reason for 3. Okay, okay, they have I think they have observed most of the normal distribution Kurtosies are having some value of 3. Okay, so that's why they have considered 3 as the average value. Okay, if it is normal distribution, then you will have the value equal to 3. Okay, I think the reason why they have mentioned is because of standard deviation, because if you see any normal distribution will be found between -3 to +3. I mean, in between 3 standard deviations. Okay, 3 standard deviations you can find, right? So I think that's the reason they have. Yeah, correct. Yesterday empirical formula. Fine. So that's why they have considered as 3. Okay, moderate value should be 3. If it is less than 3, greater than 3, okay, those are different cases. But with respect to normal distribution, it will be 0, positive, negative. Okay, so now coming back, okay, the way how you can calculate the Kurtosis, fine, is also simple. Okay, dot Kurt, fine. The what all we have studied till now, right? So that is just practically just one word. Okay, dot Kurt will give you the Kurtosis. Okay, so we'll see whether where was we where it not this, I think this. Okay, so how you have calculated, we are considering +3 to 3, but in this case we are going to consider vertical value 3. Why, sir? No, it's not vertical or it's not horizontal. It's the value is not vertical or horizontal. So it is a measure. It is a measure, Sirisha. Fine. So it's not in the vertical direction. See, Kurtosis is, see, one second. See, Kurtosis is speaking about the proportion of heads with respect to tails. That means how much tails are longer, how much head is shorter. Okay. For that, you need a some certain measure. Okay, because if I show you, there will be some formula. Okay, to calculate the Kurtosis. Okay, Kurtosis statistical formula. In that we consider standard deviation values. Yes, in empirical formula, we calculated standard deviation. Yes. See, for example, if you see here, yeah. So see, this is having some formula. Fine. So skewness also there is some formula. Kurtosis also there is some formula. Agree? So Kurtosis is defined as, okay, this very easy expected value of x. So see, what is the normal Kurtosis formula? Okay. So I'm not going into this formulas and all because you don't need to remember all this. Okay. So once you put your values into this formula, see Sirisha, once you put your values into this formula, for a normal distribution, you will get the value as 3. Fine. Why you will get it as 3? Okay, that's how it's designed. The formula is designed because if you ask like, sir, why 99.7% of the values are found between 3 standard deviations only? Why it is not 4 standard deviations? Okay, why it is not 2 standard deviations? That's a good question, but the nature of the normal distribution is like that. Okay, the way how the normal distribution is spread, we are able to conclude that we could catch all the data between 3 standard deviations itself. Okay, similarly, we also have a formula for the Kurtosis. Okay, where when you start putting these values, okay, for normal distribution, it is always coming as 3. Okay, it is always coming as 3. Okay, do you agree? Okay, so that is the reason. The average value of Kurtosis they have took is 3. Okay, average in the sense for the normal distribution. Okay, for normal distribution, they have considered as 3. And anything and the remaining are coming from this, an extension of this. Okay, but as I said, there's a specific measure for the Kurtosis with respect to normal distribution itself. Okay, where it will be 0 because this is with respect to normal. So normal, if it is actually normal, it will be 0. If it is deviating from normal, negative. Deviating from, again, positive. Okay, the 3 is coming from the formula. Is it clear, Sirisha? Okay, fine. So now if you go to the example, okay, if you go to the example, okay, I said, yeah, we'll see. Okay, saying Kurt will give the Kurtosis. Yeah, see, it is a Kurtosis. What is the value of Kurtosis over here? 0.2. Okay, now 0.2 is 0.2 is positive. Okay, positive Kurtosis. Okay, so and also I think that whatever you are getting from here, right, the Kurt is actually 99.9% it will be excess Kurtosis. Okay, so you can assume it is excess Kurtosis. If there is any change, I will let you know. But for in all the examples I've seen, right, so it is giving you the excess Kurtosis. That means with respect to the normal distribution, guys. Okay, but is the Kurtosis concepts clear, guys? Are the measures are this clear? Let me know if there are any doubts before I go to practical example. No, not clear. Okay, where it is not clear? What are your doubts? Oh, it's clear and also it's not clear. That's a great combination. Okay, fine. Then I hope it is clear. Okay, so now if you see here, the Kurtosis is like 0.2. Fine, so that means it is giving you a positive value. Okay, that means it is a bit fatter than the normal distribution. Okay, it is a bit fatter than the normal distribution. Okay, so if you see sepal width, right? If you see sepal width, if I draw sepal width, yeah, this is a sepal width diagram. So it is almost normal, but as we have seen, it is a slightly what I would say. So these tails are not visible, okay. But if you draw completely, it will look something like this. It should look something like for this lepto, right? So the lepto diagram, what we are seeing over here, so that should be resembling for this sepal width. Okay, so that's how you can calculate. That's all. Just dot skew should give you the skewness. Okay, but coming back. Okay, so there are like 4 different type of distributions over here. Okay, see, focus here, guys. You will get an idea. Okay, one is normal. What is normal? The blue color is normal. Okay, because you can clearly see. Okay, you can clearly see it looks like a normal distribution. Okay, normal distribution. Okay, now the orange one is what? Orange one is skewed distribution. Okay, this one. Okay, this orange one is skewed. Why it is skewed? You can see, right? The orange one has started like this. Okay, and then it has went something like this. Agree? It is skewed distribution. Fine. And third one is uniform. See, green is uniform. Okay, this green one is uniform. Okay, almost everything is same. Fine. And the fourth one is peak distribution. The pink one. Okay, this one. This one. Why it's peak? Because we can clearly see it is we are having good amount of tails and it is going to the peak and then it is on the length of tail. Fine. These are 4 distributions. So now we have studied 2 concepts. We have studied skewness and we have studied Kurtosis. Okay. Now we'll try to see what are the values of this skewness and Kurtosis, okay, for each of this distribution. Okay, so that you will have an understand. Fine. So the way how you can do the skew is simply dot skew. Fine. So now if you observe, okay, so if I could just okay, let me take small figure size. Just give me a second. Okay, by the time it's running, fine, I'll use this. I'm just trying to make the diagram smaller. Okay, but see here, first thing, first thing is normal for normal. Okay, so if you observe, fundamentally, what is skewness, guys? What is skewness? As I said, skewness is just a measure of symmetry. Agree? It's just a measure of symmetry. That means if you, oh, sorry. Yeah, if you see here, it is saying it's just a measure of symmetry. That means if you cut the diagram into half, vertical, like this, how much the left side portion is equal to the right side portion? That is symmetry. If it's exactly equal, then it is skewness will be 0. Okay. If it is deviating, it will be, you will have some values. Okay. But it is just a measure of these two portions. Okay. Fine. So now if you see, if you take the normal distribution, is it symmetry or not, guys? You should only tell me. Okay, it's a normal distribution. It's a perfectly symmetrical. Agree? Now, if you see the uniform distribution, okay, whatever the distribution, see, don't confuse that the normal, the skewness is related to only normal distribution. Okay, no, anything could be symmetric. Okay, as I said, if you remember in the first class, I said if this is first some mean, if the right, if the left side portion is some different distribution, and if the right side distribution is exactly similar to like that, okay, we don't know what is this distribution, but still if the left side is equal to right side, then this is perfectly symmetric. Okay, who cares it is normal or not? That is a different concept. Okay, but if it is symmetric, left side is equal to right side. Agree? Here also, if it is normal, then it is perfect. Okay, and because normal is just one type of one category in the symmetric, because symmetric could be any there could be different types of distributions which are symmetric. Okay, among that, normal is just one. Okay, fine. Now second thing is, if you see the uniform, okay, you are having this green color uniform distribution. So this is also almost, because every value is having the same like probability, even if you cut it into half, it will be almost more or less symmetric only. Okay, you don't see the left side portion is changing much from the right side portion. Agree? Agree? Do you agree? So that's why if you see the normal is 0 and the uniform is also 0. Okay. Now if you see the peak distribution, if you see the peak distribution, that is also 0. Why? Because even though it is peaked, okay, the pink color, if you observe, if you cut it into two, forget about the tails. Okay, we don't care about tails in the skewness. We only care about the left side and the right side portions. Okay, when you're cutting into half, okay, so now left side is, sorry, I mean the left side portion, okay, this left side portion is exactly equal to the right side portion. Agree? You don't need any skewness. Fine. So that's why it is also, for the peaked also it is 0. Only thing, if you see for the skewness, it is very high skewness. Okay, because if you see for orange one, if you cut the orange one into two, okay, if you cut the orange one into two, you see the left side, it is almost just like this. Okay, this orange line. But what happened to the right side? Okay, it is something like this. See, the left side portion, right side portions are very, very different from each other. Agree? So that's why there is some degree of skewness induced into it. Okay, 0.9. That means if it is 0.9, what was our range, guys? 0.9 greater than 0.5. Okay, so then that means it is between -1 to 1. Okay, it is having moderate skewness. Agree? So that's the reason I think you are able to understand why only skewed distribution is having skewness, because every other distribution, okay, they are symmetric, even though they are not normal, because uniform is not normal, still it is symmetric. Peaked is not normal, it is still symmetric, because the left side portions will be equal to the right side portions. Okay, is the symmetry clear, guys?
Yes, Santosh.
Okay, fine. Okay, now we'll also see kurtosis. Okay, just there is another way, just to let you know, there is another way how you can calculate the skewness. It is from the SkyPy stats. Okay, so this is directly you are calculating from data frame, but you can also have SkyPy.stats. From that you need to import skew, and inside skew you need to just pass your data frame. Okay, and access equal to 0 bias, these are different parameters. Okay, but the same thing you will get over here, 0.04, 0.9, 0.09, 0.05. Okay, this is using the library. Okay, I would say always suggest to go by the library because it will be more accurate. Fine. So now let's check kurtosis. Okay, the way how you can do the kurtosis is also two ways. Okay, directly by the data frame or by the use of same sky pilot stats kurtosis. Okay, same thing you can import. Fine. So now let me quickly tell you regarding the kurtosis. Okay, if you observe, fun, we'll check each one independently. Okay, if normal, it is almost zero. Okay, as I said, normal, the what is the normal blue color? Okay, normal distribution, it is almost zero. Why? As you can see, yeah. So when it is normal, if it is and it is equal to zero, what type of kurtosis it is? Is it normal kurtosis or is it excess kurtosis? It is excess kurtosis, correct? Because only in the excess kurtosis, okay, when it is normal distribution, you will have a zero. Okay, but if it's normal kurtosis, it is mod, it will be 3. Okay, but as I said, mostly we will follow the excess kurtosis part. So even in formulas also, whatever you are getting, that is the excess kurtosis with this, which is with respect to normal distribution. Okay, now when it is normal distribution, the excess kurtosis value will be equal to 0. Okay, so that's why if you see for normal distribution, it is equal to 0, the blue one. Agree? Are you guys getting, or any doubts here? Okay, fine. So now let's see the other part. Okay, so now we are having for the skewness. Okay, for the skewness, you're having 1. Why? So if you see skewness, okay, so if I just go here, take this difference. Okay, so skewness is what? Skewness is falling under leptocurtic. Okay, what is this leptocurtic? In the leptocurtic, okay, in the leptocurtic, you will have fat tails. Okay, you will have fat tails. Okay, is it happening? So that's why in the skewness, okay, which is a pink one. So you observe the pink one is a peaked one. Okay, so here, oh, sorry, which one we are discussing? Which we are discussing the skew distribution. Okay, sorry. So in the skew distribution, what is this? It is an orange one. Okay, so even in the orange one also, okay, even in the orange one also, if you see, if you if you cut it into two, okay, if you cut it into two, what is the requirement, guys? Okay, the requirement is the proportion of, okay, where are we? Leptocurtic, fine. So here also you can see, if you observe the tails part, okay, when compared to the normal distribution, okay, when compared to the normal distribution part, okay, the tails are, you are having the longer tails over here, you observe. And also in the right side portion also, okay, this diagram is cut, okay, but here the tails will be elongated in the part of skewness. Okay, so anything which is having like longer tails, right, so you will have it as a positive skewness. Okay, if you see the uniform distribution, okay, if you see the uniform distribution, fine, so there are no tails at all. Okay, almost there are no tails at all. Okay, so everything is concentrated over here itself. Okay, so that's why if you see no tails, that means very thin tails, okay, it will come under negative, or it's called platy. Okay, so as you can see, almost it's becoming, so this is becoming flat, right? So then uniform distribution is just similar to this, like it is becoming like this. Okay, so there are no tails at all. So tails are this. So okay, but here there are no tail. This is not the tail. Okay, this just support. I would say this is just an indication. Okay, but the actual distribution is starting from here. Okay, so there are no tails over here. Agree? So that's why you will have the negative value in the for the excess kurtosis. Okay, so uniform kurtosis is I would say, yeah, negative value. And coming to the peaked value, you have it is 2. Okay, positive 2. Okay, so we'll also see again positive 2. That means it will have some fat tails, or some tails longer than the medium. Okay, it should have something longer than the medium. Okay, so medium in the sense normal distribution. Fine. So if you see in the peak, if you see the peak distribution, okay, when compared to normal distribution, okay, when compared to normal distribution, okay, so if the see, this is normal distribution, so when compared to normal distribution, it is having a bit longer tails. Okay, in the skewness, because of this distribution, okay, because of distorted distribution, it is creating kurtosis. But in the peak distribution, so you will see clearly a longer tails. Okay, this longer region will affect the kurtosis. Okay, and because of the longer tails, we are having peaked is having the 2, the degree of 2 kurtosis. Okay, so these are the different distributions and the kurtosis, fine. So if it is a bit confusing, don't worry. Okay, so I would say skewness you will use in many places. Kurtosis you will not use that much, okay, but still you should definitely know and understand these concepts, okay. So once you go through the class, right, so just try to spend some time and understand this table. If you understand this table, then you will understand the kurtosis, okay, when it will be thin, when it will be fat, okay, and when based upon that how excess kurtosis is positive or negative, okay. The same thing is applied to over here, okay, nothing different, okay. So yeah guys, so that's actually about the courtesies part, okay. So is it clear? Let me know any doubts, any confusions in the courtesies. Hmm? or or you want to go through the class again, or let me know guys.
Yes, sir. We need to go through again.
Okay, fine. Yeah, so I don't think it is difficult, but it might be as a complete new thing, right? So the calculations part, you might need to understand it again, okay. So I would advise you to just go through the class once again, so it should not be any difficulty understanding. It's not any complex concept, okay. Just go through and let me know if the concept is not clear yet, okay. Just with reference to normal distribution, okay, you need to compare whether it is getting pushed up or getting pushed down, okay, something like that, fine. So okay, next thing is okay, so this is a general topic, okay. So it's a separate topic, fine. But most important thing here is we come now to a situation where, okay, so what are these actually? These are the skewness and kurtosis are, we are trying to understand with respect to normal distribution how much it is getting disturbed, okay, whether it is getting skewed or getting kurtosis, okay, that is with respect to distribution, okay. But first of all, okay, we need to understand how to find out if a given distribution is normal or not, okay. So from yesterday or from past 2 days we are studying so much about the normal distribution, standard normal, empirical formula, skewness, kurtosis, okay, z tables, z scores, etc., all this, okay. But all these are applicable when only when the distribution is normal, fundamentally agree. So now there's an important question we need to answer, like first of all, how to find out if a given distribution is normal or not, okay. Is the question valid? Yes, okay. So there are three ways how you can usually detect a normality, okay. One is through visual inspection, guys. What is visual inspection? Just by looking, visualizing, okay, how we have plotted. For example, we have plotted yeah, so the way how you have plotted, or the, yeah, so if you see just by KD plot, okay, or usual plots, a simple plot from where did we get yeah, sns.dist plot, okay. Cbound.dist plot will also give you a KD plot, or you can directly plot the distributions, okay. We have plotted so many distributions, right? Yeah, so during the histogram also, fine. During the histogram also, plot plt.histogram also, we have seen examples, right? So you can draw and you can at least get an idea. So this looks like normal, right? This looks like normal, if not perfectly normal, okay. Now how much this is not perfectly normal, how much is exact normal, that you can go with the skew and kurtosis values, okay. You can check mostly skew, you just check the skew value, from that you will understand, okay. But just by visualizing you can get an idea, okay, this is looking like a normal, near normal, okay. That is one part. Second thing is a QQ plot, which is our point of discussion. Third thing is something called a statistical test. Okay, statistical test. There are different types of statistical tests. Like something called as Shapiro test, or Shapiro-Watson, or I don't remember the names. I need to check it once. But there are different statistical tests. I will let you know once we are discussing that. Okay, but today focus will be on QQ plot. Okay. Now coming to Kiki plot, so I hope we have some time, right? Megan and Srisha, we have like 5 to 10 minutes. Am I correct?
Sir, can we continue tomorrow?
Oh, okay, that's fine. So fine. Okay, I understand. So I hope you will go through the class and at least have some revision on skewness and kurtosis. Okay, everyone, Meghna, Karthik, Sirisha. Fine. So as I said, I would like to know one thing honestly. So is the statistics seeming very hard to you guys, or are you able to understand? Like, are you in a position like just to even in the class or at least going through the class, are you able to understand or grasp the concepts honestly, so that I'll also know, or is it like extremely everything is confusing? Okay, Sirija is saying little bit confused. Okay, what about others? Yeah, ma'am.
Little confusion.
Little
For
confused.
the it's confusion, but if we go through, maybe it will be clear.
Okay, Karthik.
Yeah, Santosh, I have already discussed. So it's
Okay.
understanding while you're explaining, but suddenly if you ask next day, it's like we're going to.
Okay, okay. I
I
agree.
mean, we
Mhm.
need to definitely we need to go through like minimum 2 times. Then
Yes,
only.
yes.
Yeah.
Yeah. See, and also I'll tell you, as I said in our first class of stats is like that because nobody studies stats so much, and also it's every day. I think every day over here we have seen a new concept almost, right? So I don't see you have studied this anywhere else, okay? Right from the percentiles, quantiles, everything, okay? So we have seen, and it's a mixture of equations, mathematics, formulas, distributions, right? So yeah, what's it saying? Sir, send code notes also, we'll do practice. Yeah, Sirisha, today I'll send. Okay, today I'll say take some time and I will send you code the notebooks, right? So I will send this, don't worry. Okay, so yeah, it was like that also. As I said, I studied stats at least 3 to 4 times. Okay, because if you're at least understanding 50% of the stats in the class, then you are great. I'm really saying, because very few percent of the people will actually understand, because I also tried, because when I studied, right, so like there was not like perfect notes like how I have prepared like this, right? So I used to like extract some concepts from this source and some from another source and try to make my own notes, and again after a few days I used to come across some other course. Then slowly after some time a decent statistics I would say course has I have created, okay, or notes you can say. Okay, but initially when I started, right, it was also, I would say, not that easy. Okay, and it will be not that easy for most of the people. Agree? And as I said, you need to you should not lose track, because it's very easy to lose track in statistics. Okay, because in Python, even if you skip 1 or 2 classes, you can again cover those very easily. Okay, but in stats, if you miss and again if you don't revise or if you don't start making notes, right, it will be very difficult for you guys. I'm saying, because what all we are studying, right? So even though they are a bit difficult, okay, but I don't think they're not very difficult. Okay, at least I am trying to make them as understandable as possible. Okay, so if you're not getting time every day, at least try to spend some time on the weekend, okay, and make sure you have the notes prepared, which will come from your own understanding. Okay, because all these concepts, okay, you will see its practical application in our next module. That means in your even in the next we'll be covering NumPy pandas. Okay, immediately after that we will be going to see the feature engineering and ED, exploratory data analysis. Okay, exploratory data analysis is completely filled with statistics. What? Because the name itself is saying exploratory data analysis. We are exploring the data and we are analyzing the data. How you're going to analyze? What is there in our hands to analyze? What are the tools? Statistics. Okay, apart from statistics we don't know anything, because Python is just a it's just a programming language. Okay, we need it will just help us to write some logic. Okay, and how to write the logic, what are the syntaxes, like what is the programming language, is just a Python, but the actual code will come from the statistics. Because if you don't know what to write, then even if you have a great programming language, what is the use, right? So you should know the logic, and you should know what logic to use, and what type of checks you need to do. Okay, everything, whatever you want to do, right? So that will come basically from the statistics itself. Okay, so it's a statistics is a filter, or you can call it as a gate. Okay, and before passing that gate, we need to check like 100 things, and once we are convinced and satisfied, then we will allow that only that data to pass through that gate, and then the model training, everything will come. Okay, that will be easy. I think you will really enjoy the machine learning part. Okay, it will be very easy, and the examples or the model training part and the results, that will be very interesting and very easy. Okay, it will not be difficult. Okay, but coming to stats, I agree. Okay, but we have actually we have covered almost 50% of the stats. Okay, there are like few concepts tomorrow we are going to see. There are majorly, if you ask, there are two concepts. One is confidence intervals, and other thing is hypothesis testing. Okay, so at a very high level, you have two concepts covering, but inside that there are a few other concepts. Okay, but I would say roughly we cover like 50% of stats. Fine. So it's I would say that's why I recommend, because if you don't do it now, right, it will be very difficult. You will not again have the patience or the, I would say, sometimes interest to go back and again watch all these videos and then make the notes. Okay, then you will lose a very good opportunity. Okay, so that's why spend some time. Okay, you can see the videos in speed of 2. Okay, because lengthy videos, one, you don't have that patience to check all 1 hour video again, right? So watch it at speed of 2. If you already content good with some concept, you can fast forward, but make sure you got the gist of that video. Getting, so understood the exact what was the point in that video. You try to write in like in your understandable language in just 5 to 10 points. Make note of some distributions or formulas. Fine. So that you do, the point is you should not spend again 1 hour time later in your like career to understand that concept. Okay, now if you're spending 1 hour of time, after that when you come back it should be just 5 to 10 minutes of time. After that it should be like 1 or 2 minutes. Okay, so that is the point, right? So again, if you're spending 1 hour time after 1 month, then obviously today's 1 hour time is completely waste, right? So to avoid that time waste, you need to make some notes. Okay, so I would say that's my point. And yeah, as I said, stats is actually confusing. Most of the people will not understand. From what I have seen, they will not understand. And also, most of the working professionals, right? Even in my company or previous company, most of the working professionals also have very less grip on stats. Even myself also, I also don't say I'm a very good at stats. Okay, I know at least because that came from multiple readings or multiple efforts. Okay, so I was also not good at stats. Okay, so I would say I'm still learning stats. Okay, obviously everybody is not perfect, right? So everybody will still learn stats. There are also many things which are not perfect in stats. Okay, so but the only thing I followed was like my notes. Okay, so fundamental, I prepared my notes. That was very helpful, because if you make notes, right, so it will be like not more than 10 to 15. So you can revise the 10 to 15 notes very easily. Okay, if you learn only stats, is there any jobs available? What, Sarisha, if you learn only stats, is there any jobs available further? Oh no, only with stats. What you can do? See, that's a good question. See, what all we are doing, right? So as I said in our first class, we are collecting tools, skill set in your bag. Okay, let's say this is your bag, data science bag. Okay, so initially you stopped and you have collected something called as Python. Okay, you have put your Python. Fine. Now you are in the stats platform. So then you will collect stats. Okay, then you will collect something called as NumPy, Pandas, Matplotlib. Okay, so all these are your skill set where you are going to use. Obviously, you should use somewhere, right? So you will use these on the machine learning part. Okay, the actual machine learning part to train the model. Okay, model training, and to get some results, the practical application which will actually help in some project or some surveys or from actual project or dummy project, any sort of project. So you should see some results. Agree? So that is our goal. Okay, so all these individually, they don't have much importance if you speak from data science. Okay, only you are very good at Python. Okay, fine, very good, you got certification, but what to do if you don't apply in machine learning? Agree? So you're very good at stats, you know everything, but where you are going to apply, because application is what that matters, right? So, but if you know everything and if you're able to apply over here, fine. So that's great. Fine. So that's the reason you're actually just you're this what are you studying, right? So these are not the direct applications. Okay, a combination of all this. Okay, so once you enter the machine learning, right, so there you are writing the code in Python, you are writing the logic using statistics, fine, and you are doing some filtrations using NumPy. You are extracting the code. You are playing with the data frames using Pandas. You are visualizing using Matplotlib. Okay, you are doing some what do you say exploratory using EDA. Fine. So all these concepts will be used in a step-by-step procedure, so that you will arrive at the model which will give you some results. That's the end goal. Okay, fine. So that's the reason, but each step obviously will be important. So we are going one step at a time. Okay, so but as I say, don't lose a track, as I'm saying. Okay, because at the end of when we are at the machine learning, okay, you should not be in statistics. That's my goal. Okay, then obviously this course will not be as much helpful for you. Okay, because when we have started machine learning, you should be perfect. If not thorough, you should have a decent knowledge about all the concepts which you have studied till then. Okay, before machine learning, what we'll cover? We will cover as I said, Python, stats, NumPy, Pandas, Matplotlib, feature engineering, EDA. Okay, all these concepts we are going to cover. Okay, so as and when we are covering, right, spend some time. Okay, every day I think, see, you're not CEOs of any companies, right? So obviously, if you avoid some time, okay, somewhere you should extend the time. Okay, at least half an hour, 40 minutes. Obviously, you can do, because this is the thing which you're going to help you. This is the thing actually which will help you to get a job. Okay, in few months. Okay, if you are really passionate about this, if you are really complete the course, okay, with dedication, at least 80% of the course, definitely you are going to get good job. Fine. So obviously, if that is a result you are getting, why can't you spend at least 30 minutes or 40 minutes really? Okay, take some time and go through the class, okay, and make some notes. So that will be forever with you, okay, which will actually help you in your interview, because it helped me like anything. Okay, before interview, I just used to go through my notes. I never went through any video at all. Only my notes I have gone through, and I was able to clear interviews. Okay, that's the advice I'm giving. So if it is helpful for you, so you can follow that, or else it might create some sort of pain, I would say. Okay, so yeah, that's all from my end, I would say. So today, try to uh, complete this, and even you are sometimes you might be lagging 1 or 2 videos. Fine, that's fine. Okay, so take some time over the weekend and cover that. Okay, so yeah, guys, coming back to our concepts. So try to go through till Kurtosis, and tomorrow we are going to see how you can find out a normal distribution or not. Okay, we are going to see some tests, and then we are going to see some other distribution called as log normal distribution, and we are meeting who? Elon Musk, Ambani, and Jeff Bezos. And then we are going to see some other distribution called as Pareto distribution. Okay, few other distributions. And post that we are going to study a concept. Okay, so if at all it is not normal, how we can transform it into normal. Okay, if at all it is not normal, how we can transform it into a normal distribution. Okay, we are going to see that. Okay, yeah, we'll study in the coming class. Fine. Okay, that's all from my side. We'll meet tomorrow. Thank you, guys.